Hi, I'm Gerben.
Hi, I'm Jelle.
So Jelle, today you're going to talk about parallelism and Azure Functions.
Parallelism and Azure Functions. Yeah. So parallelism, besides being an awful word to pronounce multiple times in a single video, is of course the way we execute a kind of action, not sequentially, but multiple of the same at the same time.
Yeah. To break things up. Yeah.
Usually we could do this for performance reasons or other important concerns that we have. So if we're talking about parallelism, then there's multiple definitions of what makes something a potential parallelization target. So we have like the cutely named embarrassingly parallel stuff, where you're basically something you would put in a for loop and there's just one variable changing, and at the end, well, the variable was the only input. You could very easily make that parallel.
Yeah, and things that are stateless. I mean, things that do not have any state.
Right, but there's also you could have tasks which do need each other from time to time, but not that often. Which would still be able, you'd still be able to make that work in a parallel function, but you'd have to do some more work. Yep. And then there's of course stuff that's like inherently sequential, which you can't.
Well, one result really depends on the previous one, and you can.
Yeah. So or stuff like the most famous non-IT example would be if one expectant mother takes 9 months to grow a healthy baby. It doesn't matter how many more moms you add; it will still take
need one. Yeah,
yeah, you'd still need 9 months. You might make more than one baby, but that's a different result that we're not interested in.
Can't have 9 months to produce a baby in 1 month. The same baby.
No, that's currently scientists should get on this. Impossible. And so there's also stuff in workloads where you'd say, okay, but this is not possible to make parallel. But there's a lot of stuff that is stuff you'd like maybe to execute in a parallel function. And there's easy solutions, like we have the famous C# method parallel.forEach or parallel.forEach async, which basically you write that as a for loop. That's really, and then it runs in parallel, and you have all the performance gains. But that's not always enough, and I think you know.
And also, I mean, that's maybe that you can do something in a normal .NET runtime, but how do you do it in Azure Functions? I mean, it's serverless, stateless.
Yes.
How does it work?
There's a lot of concerns where if you just use the easy out in your code, then it works for a demo purpose. So I could cheat here and just do that and say, well, I've achieved a great performance gain here. But there's a lot of problems. So first, if you're not working serverless and you're just saying, oh, parallel for each, then you're still working on that same server. The load will increase. Yeah. You'll hit a roof, and then you will lose your performance gains. Yeah. In a serverless Azure function, for example, you won't lose that. You won't hit that roof, or at least not that quick. But if your function resets or there's an error or something, you've lost everything, and you can restart everything again. That's not something you want either.
And maybe you want to scale out horizontally. I mean, over multiple machines that are actually running your function. Right?
It seems to me that like you're talking about a sort of fan in, fan out pattern, well, fan out, fan in pattern, where we would have a single function commandeer a lot of separate functions, and they're all their own serverless entity. They're all running one of the parallel tasks, and then at the end you'll probably want to bring them all together again and do something with the end results.
That's the infamous MapReduce kind of functionality.
Yes, well, it's not that it's not rocket science, but it gets kind of rocket sciencey, especially if you're using the wrong tools. And Azure Functions, the base would be, I think, the wrong tool to use. But you know what we can use.
I think durable functions.
Oh, you're a good actor. Yes, durable functions. So I think we've talked about them previously a lot on the Betatalks. But durable functions is well, one of the use cases that that Microsoft has on their documentation is the fan out, fan in pattern. But I don't see it used as often as I think might be advisory. So I've prepared a quick demo app, and we can look at how you could achieve some parallelization.
So after this talk, everybody's going to use this if they have some job that can be run in parallel. I mean, they have to.
Right? Now you have no excuse left. So let's take a quick look at the code. And here we have a simple class. We have a conversion request. What are we going to convert into what? Yeah. I'll leave that for later. But that's if we have a lot of these. If the conversion request entails a lot of separate but let's say pleasingly parallel tasks, then we can use this application to execute that. So a conversion request would come in, and each separate task would lead to a conversion result.
Okay, so this is not the end result, but this is the intermediate result of every step.
This is the result to be aggregated.
Okay.
But yeah, as you saw, they are not very hard. So basically, they're numbers and names. So here we have a durable function, and well, we have all the basic the boilerplate, but
the basic setup that we have. Functions.
We have a separate route that I can use, and a durable orchestration client. So I'm going to be working with something that, if something goes wrong, it notices where it went wrong. It will try it. You can set up retries. You can, I haven't done it because I'm lazy, but you can add some custom error catching where you're like, okay, this is an error to be retried.
Yeah. Compensation logic or anything that you can do with durable functions.
This allows these kinds of concerns to be executed in a durable function, which would not be able to be achieved in a normal Azure function. So what it does is really simple. It takes I of course start to do some logging, because logging is, especially if you're building a demo, is your savior. Yeah. It just builds a conversion request based on the parameters that are provided in the route, and it starts a new orchestrator. So this is basically, if I make a HTTP request to this function, it will start the orchestrator for me. And then it says, all right, I've started the orchestrator for you. That's it. But the orchestrator itself is going to start up the parallelization. So here, if the context isn't replaying, then we'll do a nice little pop-up. It's a new one, otherwise it won't repeat this. This is just to show that of course we have a lot more information due to that durable orchestration context.
So that is replaying, and that's a property of the context that you get when you run a durable function.
Even though the function itself doesn't know that it's retrying, the context still knows that it's retrying. Yeah. So we get the data from the context as well, which was the conversion request. So it has a start and an end, and then it will call the activity based on that data. So the activity itself is the validated batch. So we make sure, of course, that the input that I've provided is actually a range that would be valid, which normally I would expect a bit more extensive validation logic, but for purposes. If the batch has become empty due to validation and/or was empty to start with, well, we're done. We've perfectly executed this request. Otherwise, we're going to do We're going to split these tasks up into parallel tasks, and we're going to await all of them.
Okay, so at this point in time, we don't have any parallel tasks running. This is for the setup. The orchestrator is starting. You have a start and an end. Yes. You have a validation. You know which items you want to do, and then you're going to fan them out.
This is indeed where we both fan out and where we again fan in. So we are waiting when all tasks are done, and because of the orchestration context, it will keep the tasks that have already succeeded, and if any of them fail and they should be retried, it will only retry those. Yeah. That's where you get your performance gain, even in the non-happy flow.
And I see that it's using the same kind of API that you would have when you have a normal C# running on a platform without the durable function capabilities. Yeah. it's the same kind
It's
of
really,
API.
it's not rocket science. Once you know the logic behind it, it gets really easy, and we're just creating a list of tasks, and we can weight them. And in the current function, it even looks like you're doing it on a single function. It's just that we're calling the activity.
Yes, yeah, that's what makes it that you can see that it actually calls a durable function.
That's why we have multiple functions running, and each runs on their separate serverless environment. So once all the tasks are done, we've fanned back in, and we're going to do some magic to write some results to a file so that we know that something happened. So what are we actually doing here in this cool MD5 hash? Well, the validation code is here. I'll leave that to your imagination. You can find the code linked below. But the MD5 hash function is basically something that converts a number to its MD5 hash.
Oh, I thought a SHA hash or something.
No, I want. If someone uses a number as a password, then they deserve to be. We are allowed to use MD5 hash. Yeah. Basically, this is just to simulate a longer running task, which you would not want to do sequentially, even though I'm pretty sure that
MD5's really quick.
Kind of quick, but I like demos to be kind of quick.
Understand it.
Yeah. So this is the MD5 hash function is just a function that you could run sequentially. Even you could run it with a parallel for each async. But we're doing it here as a separate function so that we can use it as the targets for the fan out, fan in. And finally, the write results to file. I'll have a file to prove that it actually worked. So if we go back to the HTTP start, we can see, all right, so we have the, this is the route. So luckily for me, again, I'm lazy. Here we have the route, and this is where we have the orchestrator. Now, I didn't clear this, so this is a previous run, but of course we can still show that it works. So we've hit the HTTP start. Yeah. Once I press the continue, it will do the entire fanning out, fanning in. So it will be really quick, even quicker than if we would do it sequentially, even though in this case that would be kind of quick too.
And do you have to know if on your machine, does it actually spin up multiple Azure Function runtimes, or is it reusing runtimes and creating functions?
Do you know?
No, I don't know.
No, it's an excellent question.
I think it should spin up multiple runtimes, but that's a guess.
I'm pretty sure it does. That's just because I assumed, and assumptions are really, really bad. So we might look into this at a later moment. Okay, cool. But currently, let's pretend that it's actually spinning up several, even though it doesn't matter actually.
No, it doesn't.
Because it's, as you can see, it's. Oh, that's too bad. I've made some edits apparently. I've hit a button somewhere. So let's
just restart.
Right. So
just make another run.
We'll start another run.
So the parameters that you provide are the start and the end.
Yep.
Of your function.
I think I hit this too quickly. And
yeah, you need to give the runtime some.
Yeah, of course. An Azure function doesn't magically auto start whenever I want it. I need to wait a bit. So let's do it like this. I think we're all set up, and we've hit the breakpoint.
The breakpoint.
Multiple times, so I'm creating a lot of output, and as you can see, it's really quick.
Yeah.
All the UI is giving back is we've started. That's the HTTP start. Sorry, the HTTP start method. It started. All the other methods, all the other functions are going behind. Even though you saw there was some logging there, but the logging is to separate targets, not to the UI in any case. And if we go to a file location that I've specified, we can see that it's starting to write text files, and this is the latest one. And here I specified in the URL the range 4 to 9. We have beautiful MD5 hashes of the numbers 4 to 9. Would I advise people to use this? Not for this use case, but you're never going to have this exact use case. You're going to have a pleasingly parallel use case that is actually probably a good target for this. And I think people misidentify pleasingly parallel tasks all the time. Yep. Especially if you're using more of a microservice architecture. These kind of patterns with durable functions are a great way to achieve parallelism. But not the only way. But I think we should save that for a different time, maybe. Yeah.
Yeah, really cool to see this introduction and how to use the stuff that's actually already there, but yeah, to put it in this use case is really nice.
Yeah,
So,
usually it's going to be this simple, and that's why I think it's important to show how simple it can be.
Okay, so thank you very much. Thank you very much for watching. Bye bye.
Bye bye.